Okay, the first half of this topic is going to hammer you with the idea of something called the critical path. So we start off with this idea that all projects can be broken down into smaller, separate individual tasks. Some of the tasks can be done independently, while others are dependent on the completion of other tasks to be done first. Critical path analysis allows us to determine the order that tasks need to happen, and also the tasks that are critical, which are the ones that must be completed for the overall project to be completed. So the first thing I want to introduce you to is the idea of something called a precedence table. Project tasks can be arranged into a precedence table with columns. The columns give you the letter label, the time duration, and any prerequisites. Tasks that must be completed immediately before other tasks. It's better to see how this works with an example. Please consider the project of making a cup of tea broken down into 7 tasks. Every year we have people argue about how to make a cup of tea. That's fine. We're going to make a cup of tea with these tasks here. You're never going to be asked a question where it's going to be up in the air like this. It's going to be more set, but a cup of tea is sort of a project that we all have some familiarity with. So do you agree that if these are the tasks, getting a cup, putting tea bags in the cup, fill kettle with water, boil the water in the kettle, pour the boiling water in the cups, add milk and sugar to the cups and stir the tea, do you agree that out of those tasks, do I need to do anything here before getting the cups? Yep, that's like the first thing in line. Do you also agree that there's no other tasks here that would go in front of filling the kettle with water? I don't need to get cups to fill the kettle with water, okay? So those are what we call independent tasks. They don't need any task completed before them, so they have no prerequisites. So can you see in the prerequisites column, I've put dashes there. But now, all the other tasks are going to have prerequisites. Please note, the prerequisites column only shows the immediate prerequisite for the tasks. We don't put all the prerequisites in front of it, just the one just before. So if A is a prerequisite of B and B is a prerequisite of E, the A is a prerequisite of E, but it's not going to be written here because we're going to already cover that with B. All right? So let's run an example. Fill in the prerequisites column in the table above with immediate prerequisites for each task. If I'm looking at putting tea bags in cups, what should I have done immediately before that to be able to do it? Yes?
Get the cups.
Get the cups. So you would put A is a prerequisite of B. I don't have a cup to put tea bags in if I haven't got the cups in the first place. What about boiling the water in the kettle? What would I have to have done immediately before that? Yes?
Well, you'd have to fill the kettle.
Fill the kettle. So the prerequisite of D would be C. What about this task E? Pour the boiling water in the cups. Yes? Yes, and? D and? There'd be another thing too, because I would have had to have something in the kettle. Huh? That's already covered. We already did that. Yes?
It's fill the kettle and put the tea bags.
Yes. So put the tea bags in the cups was B and boiling water in the kettle D. Okay? The cup's not ready for the boiling water unless it has the tea bags in there. And also, I'm not going to have boiling water if I didn't boil the water in the kettle. Okay? Add milk and sugar to the cups. Is there anything... Do I need multiple things for that or just one? Have I already put boiling water in the cups?
Yep.
Yeah.
So the prerequisite for adding milk and sugar would be E, I believe.
Yep.
And stirring the tea, I don't need to have turned on Bluey or something on the TV to do that. It would just be F. So just make sure your prerequisites column looks like that. Get cups, no prerequisite. Put tea bags in the cups. A. Fill kettle with water, no prerequisite. C. B, D, E, and F. Okay, this is where we get to the spider webs. Precedence networks are a kind of graph that we use to visualize a project and the precedence relationships between the tasks involved in that project. It's always best to draw a precedence network from a precedence table. So that's why I showed you the table first, because it's going to be easier for you to draw a network if your prerequisites are given in this form, okay? And most of the time in your Most of the time in your exam and your test, you'll get a table anyway to draw the network from. Some things you need to know about precedence network. The arrows, these represent tasks in the project. They always have a direction. The line end of the arrow here, that's where the start of the task is. The arrow end is where the task ends. Between arrows, you have things called nodes. They're either going to be a dot or later on Wednesday, we're going to make them into ovals. These are placed at the start and end of task arrows. They denote the transition from one task to another. So they just join tasks together. You'll see why we make them ovals on Wednesday. Letters, A, B, C, etc. These are written alongside the arrows to identify which task is which. So we're going to write the letters of these labels here, A, B, C, D, all the way up to G. They're going to be next to arrows. And then lastly, numbers 1, 2, 5, etc. These are written alongside the arrows too. These indicate the duration of the tasks. So when we draw a network, we're going to write a label next to each arrow, and we're also going to write the duration of the task next to on the other side of the arrow, basically. So let's try this. You're lucky now because this year they said you're allowed a note sheet and a calculator. Previous years, kids just had to remember these steps. Okay? So to draw a precedence network from a precedence table, use the following steps. What I'll do is I'll demonstrate it by answering this question and scrolling back up to the steps. The first one is draw a start node towards the left side of your drawing area. From now on, you draw from the left to the right of the area. So this question here, I'm being asked to draw a precedence network for the precedence table below. This is my drawing area. I advise you start from the left. So what was step 1? Draw a start node. Dot, start. Can you copy that, please? So from now on, step 1 tells me I go from left to right because we're a Western country and that's how we read, left to right. Step 2, find the tasks with no immediate prerequisites. Draw the arrows for these tasks from the start node and draw nodes at the end of any tasks that you drew. So what am I looking for? I'm looking for anything that has no prerequisites. Which task has no prerequisites? A. So I'm going to draw that coming out of the start node. I'm going to put a node at the end of it, and I'm going to write the label A. So did I just demonstrate what step 2 was? Find task with no immediate prerequisites, draw it out. Step 3, identify tasks with prerequisites of the tasks drawn in the previous step. What did I just draw? Yes?
A.
I just drew A. Draw the task coming out of that previous ending node. So which of these tasks here has the prerequisite that I just drew? B, C, and D. So where am I going to draw them coming out of? I'm going to draw them coming out of the end of A. B, C, the letters should go alongside. B, C, and D. Draw little nodes at the end of each of these. So we just did step 3. Step 4, keep doing step 3 until you draw a task that is not a prerequisite for anything else. When you get up to that task, you finish it off with the end node. So we're going to repeat 3. What did I just draw? I just drew B, C, and D. Which task has B as a prerequisite? E. So I'm going to draw that coming out of B. The angles don't matter that much. I just drew C. What's got C as a prerequisite? F. Draw F coming out of C. Did I just draw D before when I did the 3 of them? What task has D as a prerequisite?
G.
So G is going to come out of D. H. What are the prerequisites of H? Yes?
E, F, and G.
Good. So H needs all 3 of them. Do E, F, and G, do they converge right now?
No.
You You didn't know that in the first place. So you're allowed to do corrections afterwards. E, F, and G have to converge. So I'm going to correct them by doing this. And I'm going to scrub that out. That's going to be G now. That's going to be E now. And then what does H require? H requires E, F, and G to have happened. Like that. And what did step 4 say? You keep doing step 3 until you draw a task that isn't a prerequisite. Does H appear in the prerequisites column? No. So you finish H with the end node. So that is why in your exams they offer that you draw graphs and pictures and stuff with a pencil. If you just scrub it out, they realize that you have limited time. So as long as you've corrected it, right, and clearly labeled, you'll be fine. They're not going to mark you down for that. One rule, just make sure that you don't have lines crossing over each other. Okay? If required, apply corrections to ensure task arrows are not crossing over each other. Okay? So can you get that precedence network down? I want to make use of this extra precedence table we have up here and practice drawing this one. Try to remember those steps. We start on the left side of my drawing area. So I've got a tiny drawing area here. Start. What was step 1? What tasks have no prerequisites in the making the T one? Yes?
A.
And?
A and C.
A and C. So both A and C are going to come out of the start node. We're just practicing those rules again. End with a node, end with a node. I just drew A and C. So I need to look for tasks that have A and C as a prerequisite. What task requires A? B. So I'm going to draw B coming out of A. What task requires C? D is going to come out of C. We're up to E now, but what do you notice about E? What does E require? Both. So I need to do a correction here because B and D aren't connected right now. So I'm going to erase instead. I'm going to join them. B and D, and with a node. E is going to come out of there. Junction. What does F require? F requires E, so it just comes out of E. What does G require? F, so it comes out of F. Is G a prerequisite of anything? No. So what do I draw at the end of G? N. Get that down as an extra practice. You'll practice plenty on your timeline. Okay, last thing to cover is the idea of the critical path. When a network is drawn with duration numbers, then there's going to be certain paths through the network that will take longer than others. The critical path through any network is the longest total duration from start to end. Because it's the longest path, it represents the tasks that must be completed to complete the overall project, so they're considered critical tasks. Let's have a look at this one here. Consider the precedence network below. You can see there's numbers now representing duration. I think this is the T one. The numbers represent duration in seconds. Identify the critical path through the network and thus the critical task. I'm going to highlight the top pathway. So that pink path, possible paths. How many possible paths are there through this network? There's 2. So the first one would be A, arrow, B, arrow, E, arrow, F, arrow, G. How long would that take? 15 and 10, 25, 35, 45, 50. That would take 60 seconds to go through A, B, E, F, G. Is there another possible path through this network? Yes, what is it?
C, D, E, F, G.
E, F, G. How long would that take? 20 and 100? 120? Yes?
155.
I think so. Let me check. 100, 120, 30, 45, 155 seconds. And so from the notes above, what did we say the critical path is? It's the longest path. What is the longest path? C, D, E, F, and G. And hopefully this illustrates what we mean. Sometimes people get hung up on what the critical path is. They often get confused. Why is the longer path the critical one? Because is this cup of tea going to be fully made if I waited 60 seconds? No, because I have to sit there and wait for this to happen. It's like in McDonald's, you're making your burger. If you got a slow person, that burger's not going to be made until the slowest path has been taken. So the critical path is the path that determines the overall project being done. And the overall project being done is only going to happen through the longest path through it. Because otherwise it doesn't get done. Yeah? So what you'll notice in the book, I haven't changed the timeline. That's the minimum. But what you'll find by the end of this topic is you want more practice. Okay? So I might as well suggest straight away, do 1, 2, 4, 6 as a minimum. But you'll find before the test that you'll want to go back and do the ones in the gaps anyway. So you might as well just do them there. There's not many questions. So that is critical paths. That's precedence networks. That's precedence tables. That's the end of the video.